We talked about prime numbers briefly at the end of the last lecture, but I want to start off by being precise about what we mean by one. Prime number is an integer that has exactly two factors, one and itself, and a composite number is just the opposite of a prime number. It's a number that has more than two factors. Now, we're going to look at some more examples here in a minute, but just to get us started with some obvious numbers. 3 is a prime number because while 1 and 3 do go into it evenly, the only other possibility would be 2, right? That's the only number, only other positive integer that's less than 3, and 3 doesn't go into 2 evenly, right? So because 3's only factors are 1 and 3, it's going to be what we call a prime number. Take 6 on the other hand. 6 is a composite number because in addition to 1 and 6, 2, for example, also goes into 6 evenly, so it's a factor. And 3 also goes into 6. So 6 has several factors other than 1 in itself. That's what puts it in the composite category. All right, so we saw in the last lecture that determining the factors of a number can be a pretty tedious process. It's doing a lot of repeated division problems, and it just gets worse as the numbers get bigger. Now, fortunately, there are some rules we can use to quickly determine if one number is a factor of another. For example, to see if 2 is a factor of a number, all we have to do is look at the very last digit and see if that's divisible by 2. So for example, 42 is divisible by 2 because this last digit, 2, is divisible by 2. And on the other hand, 41 is not divisible by 2 because its last digit is 1 and 2 doesn't go into 1 evenly. So I got a bunch of other rules here. A lot of them are pretty similar. The rules for 2, 4, and 8, for example, are all very close to each other. To see divisibility by 2, you check the last digit. Divisibility by 4, you check the last two digits. So for example, looking at 116, 16 is divisible by 4, which means 116 is divisible by 4. And for 8, we again do the same thing except for looking at the last three digits. All right, so for 3, we look at the sum of the digits. This is kind of a weird one. All right, so say I give you a number like 147. Well, if you add up the digits, that's 1 plus 4 plus 7, which is 12. All right, well, 12 is divisible by 3, which means 147 is divisible by 3. A very strange kind of rule there, but it comes in handy. And down here for 9, 9 is very similar. We check the sum of the digits again, and this time to see if they're divisible by 9. Right? If they are, then so is the original number. 5 and 10 are pretty straightforward. You just look at the last digits. If the last digits are 0 or 5, then it's divisible by 5. And if the last digit is 0, then it's divisible by 10. And finally, I want to take a look at 6, because this is going to lead us to another really useful rule here. 6 is equal to 2 times 3. Right? So to see if 6 is divisible, if a number is divisible by 6, we just check the rules for the individual factors. And if it's divisible by 2 and 3, then it's going to have to be divisible by 6 as well. So that leads us to another kind of useful rule here. One number divides a second number if and only if all of its factors divide the number. So that's what I'm doing here with 6. Right? Instead of looking at 6, I'm looking at the factors of 6, checking both of them, and again, that gives me a yes or a no. So let's look at an example here. Right? I want to look at 105, and really what I want to do is determine if it's prime, which means seeing if there's any number other than a 1 and 105 that goes into it evenly. Right? Well, 2 doesn't. We can cross that one off because the last digit here is 5, and 2 doesn't go into 5, so 2 isn't a factor. All right, so how about 3? Well, if we add up the digits, 1 plus 0 plus 5 is 6. 3 does go into 6 evenly, which means 3 is a factor of 105. Because 105 has a factor other than 1 in itself, the answer here is no, it's not prime. All right, but let's keep going here. Just check out the others just so we can get a little practice with the rules. Is it divisible by 4? Remember our rule down here, right? 4 is equal to 2 times 2 because one of its factors, because 2 doesn't go into it evenly, neither does 4. And what that really kind of tells us, right, is that any number that has 2 as a factor, we have to rule out, and that's all the even numbers. So I can automatically cross off 2, 4, 6, 8, and 10. Okay, well, how about 5? Well, the last digit is a 5, right, which means 5 is a factor. And looking down here at 9, remember 9 is 3 times 3. So because 3 isn't a factor, 9 isn't going to be a factor either. All right, so get a little bit of practice there, but really all we needed was the 1. As soon as we saw that 3 went into it evenly, that was enough to answer our question. All right, so we've got another number here for us to look at. It's a little bigger now, right? And we're going to have to do a combination of looking at our rules and the brute force method that we used in the last lecture. The rules at this point they're going to help us to narrow down the list. Right, so remember our rule for determining how far we have to go. The square root of 227 is 15.007 something, which means I only have to check numbers up to 15. Okay, well, one I probably even should put on here. 1 is a yes. 1 is a factor of every number. 2 is not a factor because 2 does not go into 7 evenly. Remember what we talked about on the last slide. If 2 doesn't, then every number that has 2 as a factor doesn't. So we also have to cross off. See, we get these for free now, right? I get to cross off literally half the numbers. I crossed off all the even ones. Right now for 3, look at the sum of the digits. 2 plus 2 plus 7 is 4. 4 plus 7 is 11. 3 does not go into 11, which means 3 does not go into 227. And again, that rules out every multiple of 3. So we're also going to rule out 9, and we're also going to rule out 15. Okay, now let's see. How about 5? Well, the last digit is 7, not 0 or 5. So 5 isn't a factor of 227. And now, what are we left with? Well, we're left with 7, 11, and 13. Right? So at this point, there's no fancy tricks for these numbers. There actually is a rule for determining if 7 goes into a number evenly, but it's a bit of a hot mess. Frankly, most of the time it's easier to just go ahead and divide by 7. So 227 divided by 7 is 32.42 something, not an integer. So that's off the list. 227 divided by 11 is 20.63 something. Again, not an integer. So 11 isn't a factor. And finally, 227 divided by 13 is 17.46 something. Also not an integer. Right? So what we've seen here is that the only factors of 227 are 1 and 227, which means the answer to this one is yes. 227 is a prime number. Okay, so in the next lecture, we're going to continue this discussion about prime numbers. And what we're going to do is we're going to look at how we can take a number and rewrite it as the product of prime numbers, right? What's called its prime factorization.